Welcome. Some lists behave like onions, they have layers inside layers. Working with such nested lists is a common real world problem in data processing. APIs, JSON data, AI pipelines, and even with web scraping data. Today, you will learn a magical technique called recursion. So, we have a list as you see, and we have to convert this list into this resulted one, the flattened list. So we have a nested list. Inside this list we have another list. Inside this list we have another list. So we have a nested list and we have to convert to this one. So today you will learn a magical technique called recursion, which helps Python solve such deep problems by calling itself. We will break it down so clearly that recursion will never confuse you again. So so let me zoom in, and we have I am going to define a function with name flatten, and here I will pass a list. So for let me create one resulted list here with empty to store the empty list inside result variable. So after that, for item in list, and if item if instance item is list, then result dot extend with flatten, and I will pass this item here to call itself again, and after that inside else block result dot append then item. So at the end of our loop, return result, and then I am going to print this flatten, and I will pass the nested list to this flatten function. So what I did till now, let me explain each and everything. If you are new on this channel, don't forget to subscribe and like. Before explaining the code part, let me explain one thing. So recursion, a function calling itself is called recursion. So recursion is nothing but a function calling itself. So as you see in this example, this flatten is calling from here, from this point. So same method is calling the same method. So a function calling itself, this flatten is calling itself from here on this point. So we are applying the flatten, a recursion function. Before going to this code, let me explain the recursion concept with simple example. Def say hello, and I will provide nothing to it and print hello, and I want that say underscore hello. So if I comment this code and if I run this, clear the terminal, and if I run this, save the code, let me show you, and we have to call this say print say hello. If I call this, if I run this code, you will see I am getting hello, maximum recursion depth exceeded by calling a Python object. So as you see here, I am getting previous lines repeated 993 more time. So on this calling, they will print hello, call again and again. It will show us an error, previous line repeated 993 more time, and recursion error, maximum recursion depth exceeded while calling a Python object. So basically this line calls itself again infinite infinite loop. They are calling itself infinite time loop. So but in our code, let me clear this and let me uncomment all this. Let me explain this, what this code will do for us. Let me clear the terminal, clear terminal. So in our code, the recursion will solve our problem smartly, not will run the flatten infinite time. In this code, the recursion function stops when the item is not a list. It goes deeper only when the item is a list. Let me explain this code step by step. In step 1, in step 1, we call flatten with nested list. This list, so we call this flatten with nested list. The list is this one nested. We call a method flatten with the nested one on step 1. After that, result variable define with empty list, and then loop starts. Then loop starts here for item in list. Loop starts, as you see, the first item is equal to 1. So for item in list, the first item is 1. If is instance item is not a list, item is a number. So result dot append item, the result on item 1, this is not a list, so not a list, then result dot append with 1. So item is, when item equal to 1, this is not a list, then result append equal to 1, result append with 1. Now the result will be like this. After that, item equal to this one. If item is list, then as you see item is a list, it is a list when this is a list. If instance item is a list, then result dot extend, then it will call flatten and with this list. It is a list, then call flatten. On this step, it is calling flatten with the list one, with list, and this is called recursion. It is calling itself, and we jump inside again. So on step 2, we are inside call. So we have item equal to true. So when we pass item, the item is a list. For item in list, inside list we have 2. So item is not a list, item is a number, then result dot append, result will be 1 and 2 on item 2. So after that we have 3 and 4. When if item is a list, then is if instance item is a list, then result dot extend with flatten. This is called itself again with 3 and 4. Item 3 and 4, when item 3 and 4, and this is nested list again, when this is listed list again, so it is called again flatten with 3 and 4. providing this list. So the recursion, this flatten will call itself again. So the step 3 we are inside call again and flatten have the list with 3 4. Then when we provide this list to flatten, if item in a list, if is instance item or not, if item is not a list, then result will be item 3 becomes append, and then item 4 append with result dot append with 3, result dot item append with 4, with 3 and 4. After that, now as you remember, we have a with result with this, we have result with 1. At the top level we have result with 1. Then when we provide the nested list here with 2 2 3, then result becomes 2, and this is our step 2, this is our step 1. So on extend, as you know, the dot extend of Python on applying on list, this extend means add each element, not the list. Extend will add the item, not the list, each element which we provide with this list. So now here the result will change to 2 3 4, and the next item in step 2 is 6. In step 2 we have the next item is 6. So append will becomes 2 3 4 6, and then return the list upward, and we were at result equal to 1, and we now do result dot extend with this one 2 3 4 and 6. So result dot extend 2 3 4 6. Now the item equal to 7, as you see here. Now the item is 7. Then append becomes 1 2 3 4 6 7. So, and then return the result. Let me run this, and it will give us what the result will be, this one. Let me run this. As you see, I am getting the same result which I explain you each and everything here. So why dot extend instead of append? Why dot extend instead of append here? So understand this. This is trick point. Result dot append would add the list. Let's say this list is 3 or 4. So if we use the append would add the list as one item, not. So we not want to add the list as an item, we want that to add the item inside this list as an item in result. So the append would add the list as one item. That's why we use here the extend. And when we provide this list to this one to extend, basically extend spreads the item, and then we will get this will add the item to the result list like an item, not a list. Let me explain the time complexity of this code. So as you know, every element is visited once, so the time complexity so every element visited once, so this becomes big O. And if nesting is deep, recursion is taking cost but still linear. So here question arises, what are the practical uses of this code? So if you work with JSON APIs, if you work with data cleaning, Excel or CSV list, web scraping data, or AI embedding or big data transformation, so this example will help you there. So if any doubt, no, please comment it. I am here to clear your doubt. Let me explain. Let me remind what we did inside this code. This function looks inside each item. If the item is a list, it calls itself to flatten the list. If the item is not a list, then if item is not a list, add it to result. This extend puts the flattened child list into parent list, and recursion keep going until everything is unpacked.